So thinking back over everything we've been doing, this section is kind of a review of linear and exponential. The first problem here wants us to talk about the form of our equation and two characteristics. So the form of this first one is our slope intercept form. So two characteristics we can take for that. Remember, we talked about the form y equals mx plus b. That's what you're looking for slope-intercept form, where you have an m, an x, plus a b. M is your slope, so our slope here is at -7, and then b is my intercept, so I could say my intercept is at the point x is 0, y is 2, and that would be my intercept for this problem. This next one, we didn't really end up going over this a lot, but this is your slope point form. Again, this is a pretty easy form. So the slope point form, you have your point, right? So what these generally look like is y plus a equal to your slope, so still m, and then x plus b. So this is my slope, and my point will be my point here would be -b, -a. So we're going to want to change the signs of what we see. So how would that look in this problem? Well, slope is m, so m is 2/3. And my point here, I take my b, which is right next to my x, and I'm going to change the sign. So that'd be 5, comma, -2. Okay? So those are two different forms for linear problems. The next bunch of questions are great. These are rate of change questions. So this first one, for instance, wants to know the rate of change from 3 to 5. Okay, so they want to know this range. So rate of change for a quadratic function, we're going to use our slope formula. So y2 minus y1 over x2 minus x1. We have our x column and our y column. So I got y2 down here with the 5. I got y1 up here with the 10. We've got x1 and x2. And we're just going to plug that in like we would do for any normal slope problem. So I really like these rate of change just because they're so similar to what we would have done before. So we have 16/2, which is just 8. And this is another one. We want to find the rate of change for an exponential function. Guess what? You look for the numbers they ask for. So x2 and x4, and we're going to plug them in. y2, y1, x1, x2. 256 minus 16, so we have quite a big number up top. 4 minus 2, we get 240/2, which is 120. So you can have big numbers here and exponential growth. We're going to expect a really quick rate of change. Then I want you to do that with a graph. We're still looking for the rate of change, right? So we want to find these intervals. So my point at 0 is the point x is 0, y is 1. And at 2, I have x is 2, y is 5. We got 2 points. We do that slope formula again. So 5 minus 1 over 2 minus 0, which would give me 4/2, which is just 2. And my next one wants me to do the same thing, only now we want x is 2, which we've already labeled that one, so we can leave that there. And an x is 4, so 4, it looks to be that we're at 10 here. Okay. Alright, is that 3 or 4? Just double checking that I have the right point there. Oh, it looks like I've gone off my graph a little bit. So I'd want to recalibrate that way for my 4. Oh, I'm sorry, I have the wrong graph. That would probably help with my problem here, wouldn't it? This graph is down here. So this wants us to do with this graph, and they've already labeled our points here. So I see 4 and I see 2. 16 minus 4 over 4 minus 2, which will leave us with 12 over 2, which is just 6. So use the pattern shown in the table to predict the rate of change. So we're once again in a rate of change problem. Okay. So we're trying to predict. So what we see here, right, is we want to know what would happen at 14 to 15. So we stop here at 11, 12. So, 11 to 13, what would happen? Well, if we look at our rate of changes, right, it looks like they're going down 2 every time. So down 2 from 11 would be negative 13. If we did 13 to 14, this is just continuing my pattern. No hard calculation. Subtract 2 again, I would get negative 15. And so if I was going to go down to 14 to 15, which is what my question asks, I would have negative 17. So it's just following the pattern that you calculate over on the side here. And once again, this wants to know about 8 to 9. Again, I like to just extend out my patterns. So 6 to 7, 7 to 8, and 8 to 9. This time, it looks like my pattern is multiplying by 2. So to go to my next one, 32 times 2 would give me 64. 64 times 2 is going to give me a 128, and then 256 would be my answer for 8 to 9. So it's just using your calculations that you have. Okay, so rate of change, pretty simple. It's either slope stuff or, extending out these tables. This one is a little bit harder to identify the x and y intercepts and the vertex on the graph, but let us start with our vertex here. Remember, your vertex will equal negative b over 2a. So let's plug in all of that information. Remember, we have a, b, c from previous unit, so negative 14 over 2 times 2, which would give us negative 14 over 4, and I'm going to simplify that to 7 over 2. Okay, you could also make that a decimal if you wanted, which would be negative 3.5, which will be easier for us to calculate with in a minute. From there, we want to plug in our 7.5. So we have 2 3.5 squared plus 14 times 3.5 plus 20. So you use that simple formula, and we're going to calculate out all of this. Be careful with your negatives. Make sure, I dropped it actually. You should keep your negatives in there with your 3.5. And so you could enter this into a calculator, calculate it all out, and you would end up with y equal to negative 4.5. So this point would be negative 3.5 comma negative 4.5. And that would be your vertex. So that's something that I would use, since these are a lot of multiple choice, to kind of simplify my answers. Okay, to not have to do the intercepts. To do my intercepts, what I'm going to have to do is calculate out, let's actually start next with the next easiest one, which is going to be, so we did our vertex. So if you had answer choices, get rid of ones that don't have this vertex. The easiest one is actually our y-intercept. Okay. Yes. So y-intercept is going to be the point at 0, comma, c. So it's nice and super easy. That is what your point for your y-intercept. So whatever x is at 0. So I'm plugging in 0 for x, and I'd be left with 0, comma, 20. So it's just whatever's in the c position. So again, you have those two pieces of information. At that point, you may be able to start to simplify. And then the last piece to get your x-intercepts, the x-intercepts are a bit more work. Oh, ooh. That's what happens when I let my little sister have the computer. So x-intercept, this is where you're going to have to go back to that quadratic formula. So that negative b plus or minus the square root of b squared minus 4ac all over 2a. And you'd want to plug everything in. So plugging this in, I would get negative 14 plus or minus the square root of b squared, which is 14 squared, minus 4 times 2 times 20, all of that over 2 times 2. And of course, we would want to simplify that all down, and we would get the point negative 2, 0, or the point negative 5, 0. It's a little bit of simplification, but that's what you are doing there. And then our last one is just reviewing our different parts for our exponential functions. It says identify the y-intercept. Remember, y-intercepts are just the value at 0. So y-intercept is going to equal 3 to the 3 to the 4th. Replace x with 0. Well, anything to the 0 power is 1, so we get 3 times 1, which is just 3. So our y-intercept to the point x is 0, 3. So that's a pretty easy one to calculate. And increasing or decreasing, remember, we think about 3 over 4, which is equal to 0.75. That is less than 1, so this would be a decreasing function. So it's a review of a lot of things that we've looked at. If you have any questions, let me know.